Hello everyone. My name is Yasir. Today I'm going to present my project, which is AI video dubbing platform. This project uses artificial intelligence to automatically translate the dub videos into different languages while preserving the original speaker's voice. It also supports optional lip synchronization to make the dub video look more natural. So, here is the interface for the platform. Here we can see we can upload a video, and then it processes the video and converts or dubs in another language which we want. Here we can select the languages. Okay, so firstly I'll demonstrate how the platform works in real time. This is the application interface. First I'll upload a sample video. Let be this video. So this is a video in Indonesian language. Okay, first I can show you the video.
Gimana caranya berpikir kritis aja kan sebenarnya kan. It's a general question. Dari pengalaman gue pribadi, kritis itu bukan karakter bawaan. Kritis itu adalah disiplin.
So I'm gonna convert this sample video into we can say in Hindi language. Let's assume we wanna change this dubbed video into Hindi language. Okay, so here we can just select different languages which we want. Suppose we are as we want to change it in Hindi language. Already we uploaded the video. We can just press upload and quick job. Here it has started extracting the audio. It will process the video. Now I'll show you in the Docker. See, the video, the task has been accepted, the task has been received. As you can see, it's working. As you can see, it's working in real time. It'll, it'll take some time and process the video. Here you can see all the files of this video. I have already uploaded it on my GitHub. We can monitor the job status here. As you can see, diarization is happening. So when the processing is done, shows like a completed sign here, and here you can see there is a download option right here. The lip sync is not working right now in my current computer hardware. When I tried it on Kaggle, it worked. Just because I don't have that uh, hardware potential right now with myself. It was working on the Kaggle notebook. So here you can see uh, the download option is here, and if I try to download it, it will be downloaded. Let's see. Yes, you can see it's downloaded. Now if we try to open this file.
आप कैसे सोचें? यह एक सामान्य सवाल है। मेरे व्यक्तिगत अनुभव से यह आक्रामकता स्वाभाविक नहीं है, यह अनुशासन है। जैसे तुम हर महीने अपने पैसे को अपने साथ रखते हो, वैसे ही हर सुबह उठते हो और अपने बिस्तर पर
So now that we have seen the application in action, let's understand how the complete system works internally through its architecture. So now we are going to understand how the architecture of this project actually works. So firstly, there is our client. Okay, The client uploads the video. The workflow starts with the client. The client can be a web application, Postman, or any application consuming the API. The client here performs three main operations like upload a video, check the processing status, download the final dubbed video. All the communications happen over standard HTTP requests. Next, the fast API service. This API layer, as you can see, this API layer, what it does is the uploaded video is received by the fast API service running on port 8000 in my case. Okay, this acts as the central controller of the system. It provides multiple REST APIs such as post post videos, upload, get videos, ID status. Basically, the status video upload, uh, the get download to download the final output, delete endpoint for removing jobs, health endpoints for monitoring. Instead of processing the video immediately, Fast API creates a new job and then it it comes down to the database. After receiving the video, Fast API stores the job information inside the database using SQL Alchemy. The database stores information like job ID, current status, and progress, transcript, etc. The SQLite is used during development, while PostGRE SQL can be used in production by simply changing environment variables. Okay. The next is the file storage. The basically the file storage is the uploaded video itself is stored inside the file storage volume. The storage keeps all the uploaded videos, extracted audio, temporary audio segments, speaker references, clips, etc. Okay, keeping files separate from the database improves scalability actually. That's why. So the next is the queue, the task queue, the Redis queue. Okay, here as you can see, instead of making users wait several minutes, Fast API places the job inside the Redis. Redis acts as a message broker. This creates an asynchronous processing pipeline. As soon as a worker becomes available, it picks up the queued job. Okay. The next is the salary worker, which is the main pipeline. Okay. Here, this entire AI pipeline is performed by the salary worker. This worker can run this worker can run multiple replicas, allowing multiple videos to be processed simultaneously. Here, the you can see the AI pipeline. Okay. Firstly, we have the the audio extraction. The first step is extracting the audio from the uploaded video using FMPEG. The video is converted into a clean wave audio file, which is wave format file. Okay. Then next comes the speaker diarization using Pianode 3.1. As you can see, this one. This identifies who is speaking and divides the audio according to the different speakers. All right. The next come is the transcription. Here, the speech transcription is performed. Each audio segment is then passed to faster whisper. Here, whisper converts speech into text while maintaining timestamps. Okay. Then the translation is done. The generated transcript is translated using you can see Meta's NLLB 200 multilingual translational model. This allows translation into many different languages. Then the the natural the natural voice keeping part is here, which is voice cloning. After the translation, XTTS version 2 performs voice cloning. Instead of using a robotic voice, it learns the speaker's voice characteristics, and generates speech that sounds very similar to the original speaker. Then the sync and mux is done. Since translated speech is often longer or shorter than the original, the generated audio is stretched or compressed using audio time synchronization. After the synchronization is done, the dubbed audio is merged back back with the original video. Then here's a feature of lip sync, which what it does is optionally the wave to lip adjusts the speaker's lip movements so they match the newly generated speech. This makes the dubbed video appear much more natural. And finally, the GPU runtime. Here, the most AI models, as we know, require GPU acceleration. The worker runs on the CUDA using PyTorch. PyTorch. Heavy AI models are loaded only when needed, reducing the memory's usage. But even I also have a hardware limitation, so it's not more than 8 GB of VRAM. As you can see, uh, during every stage, the worker continuously updates the database with you can see you know these arrows. During every stage, the worker continuously updates the database with the current processing status and progress. This enables users to monitor the job in real time. Then finally, when the output finally the after all this processing is completed, the final dubbed mp4 file is stored in the file storage. Here you can see here. Okay, the API then changes the status to completed. Finally, the client downloads the finished dubbed video using the download endpoint. Overall, the architecture separates the application into independent components like fast API. The fast API manages the API request, Redis handles the asynchronous task, queuing, Celery executes the AI pipeline, the database stores metadata and progress, file storage keeps the media files, GPU acceleration powers the AI models. This modular architecture makes the platform scalable, efficient, and capable of processing multiple video dubbing requests simultaneously. As you saw on the last sample, that how it's uh, dubbed in Hindi, as I showed you. So that is the sample for this, and and this is how it works. Okay, thank you, thank you all.